Hi, my name is Josh, and today I'm going to go into a demonstration on how you can use the Godot game engine to program agent simulations on your computer. We're going to go into how you could set up a pandemic style simulation where you're getting agents sick and then they are spreading that sickness to other agents, and you can change what happens when they're sick and see how that behavior affects the outcome of the simulation. And this is going to be open a door of possibilities where you can try adding your own agents for different fields or try to program different scenarios using your own knowledge and interests. So let's just get right into it. I am in Godot version 4, beta 7. So hopefully this is the latest version out in beta right now, and I want it to be future-proof. So if you're using the GD script for Godot 4, it should have all the same syntax. So let's get started. And there's a starter project with the assets below to get started in the description. So you can go and download that if you want. I'm going to begin the demonstration by just creating a new project. And I'm going to call it Agent Simulations. And now I'm going to choose mobile instead of forward plus because you're going to be rendering a lot of agents, and it's not going to need a very complex scene, and we want it to be render faster, simple scenes. We're going to be in the 2D version of this. So I'm going to select there we are. Going to create a new folder, Agent Simulations. That'll hold all of the assets and project files. There we go. Mobile, we're going to use Git. All right, so first let's go to the 2D renderer and let's create a 2D scene to be our base for the scenario. So I'm going to go Control A while I'm selecting Node 2D, and I'm going to search for a color rectangle. And this color rectangle is going to be the background for our scene. So I'm just going to drag it across, make it a nice light blue color. All right, now let's get the barriers in so that the agents don't walk off the screen. To do that, you can create a 2D node for holding all these containers. I'm going to do a basic node 2D as sort of a parent for all of these. Then I'm going to create a rigid body. Sorry, I meant to say we're going to get a static body 2D. And now that static body 2D needs to have a shape. That static body 2D node is going to need a shape, so going to add a collision shape, and we're going to make it a rectangle shape. Drag it into position, go for the top one, and then you can just duplicate it, and then drag your next one to the bottom. And now we can duplicate it again, but we want it to be different shape than this horizontal rectangle, so we're going to go here. We're going to reset, make it a new rectangle shape, and then we're going to drag it upwards to match the vertical walls, just like that. Then you bring that there. Perfect. All right, so this will be the walls for our simulation. Now I'm going to add a player character, which is going to interact and set off the chain events. So I'm going to hover on the main node 2D node, do a Control A, and then I'm going to do character body 2D. And now you'll need multiple things for the character body 2D. First, let's get a sprite so that we can see what we're doing. I'm now going to get a texture from the assets, which is simply right here. And all these assets will be provided in the link down below. So I'm just going to make it the player. And I do that by just dragging player over into the texture slot. There we go. That's a little big for my liking. I'm going to hold down Alt and then Shift so it's a uniform scaling as I'm dragging down to a smaller size. There's about fine. And let's see, you also need a collision shape. Because it's a circle, we're going to make it a circle shape 2D. You can scroll in using the mouse wheel and then pan by clicking and holding the mouse wheel. And I'm just going to drag that to be a little bit bigger than the exact player. All right. Now, let's add some movement to the character by adding a script, and you can do that by highlighting the character body 2D node and adding a script like this. And then I know what I want, so I'm going to check off the template, make it empty, and then I'm going to name it something like player movement. Awesome. So to start with, let's get the input by defining a function using the func keyword and then just saying get input to be how we're going to grab the input. And we're going to start by defining velocity, which is to be an empty vector 2, which is a vector 2, if you're ever curious. You can easily hold down the control button on your keyboard and then hover over things that you may be confused about, and you can click on that, and it opens up Godot's built-in documentation, which is very handy. And a vector 2 is basically just a tuple containing two floats in this instance. So it's going to be the position, well, in this case, the velocity, which will be a vector in whichever direction we want the player to go. Excuse me. So you can go back to the script by clicking on the script. If it's documentation, it's documentation, but we're going here. And now we're going to check if input.is action pressed, and we want UI right. So we're going to do it in strings UI underscore right. And then after that, we're going to say that the velocity, specifically the x parameter, plus equals 1. All right, so now I'm just going to copy and paste this 4 times for the 4 different directions. We want UI left, we want UI down, and we want UI up. In the case that we're going left, we actually want to minus equals 1. If we're going down, we want it to be y plus 1. If we want it to be up, we're actually going to do a y minus 1, because the coordinate system in the 2D plane, the lower on the screen you are, the higher the y value, and the further up you go, 0 is the top of the y value in the 2D renderer. So, and then after that's been edited, we're going to do velocity is equal to velocity dot normalized. This will set the vector to simply be a 1 or a uniform vector that'll have a length of 1 in whichever direction we're going. Say we're going right and up at the same time, we're going to have an arrow going like this. So we don't want that to be too long because it's +1 and +1 and it's going to be this long. It's way longer than just one of these. Or we want it to be equivalent to a circle in the arc. It's just going to be this long. So after that's normalized, we're also going to multiply it by speed. And what's speed? Speed is going to be a variable that we define up here. Speed equals, let's say, 400 in a float just to make it easier. And also, if we want to edit that in the editor, we can add an export flag using the @ symbol to make it editable outside. So after that, let's actually make it move by doing a physics process function. And a physics process is called every frame, and it will update our movement, and we're not going to wait for it to render anything. We're going to make sure that we actually move so that there's no lag in our movement. So we're going to call the get input function. We're going to move and slide. Move and slide actually moves the character body off of the velocity variable. So velocity is an internal variable that already exists, and it's going to move itself according to that velocity. So let's go back to our scene in 2D, and we haven't even named the scene yet, so let's do a Control S to save, and let's just name it simulation. Save in the parent directory. And we don't want it to be spawned off the edge, so let's just click and drag specifically the character body. Let's make sure that we're clicking the exact character body. So you can do that by adding this right here, and then that'll select all the things on top of each other. And I say I want the character body, which is the player. Let's actually name it player to be a bit more specific. Select the player again, this is kind of useless actually, because I keep clicking the collision shape. If you don't want to collect those two things, you can just turn those off and then select the player itself. There we go. Now we see that we're dragging the player. Then we can turn those back on. Now it's a lot more feasible. If we don't want to select any of the children, we can just go over here and lock it down using this. So now we've grouped the nodes together, and when I'm selecting on the player, I want to move the whole player instead of the sprite or collision shape explicitly. So let's test to see it works by pressing the play button and then selecting the current scene as our default scene. All right, if you're using the arrow keys, you can see movement. But I'm a gamer, and I don't want to use the arrow keys. I want to use a different inputs instead of just the arrow keys, because that's kind of annoying. I want to use my left hand. So to do that, you can just go into Project, go into Project Settings, and then click on the input map. And then we're going to look for UI. We're going to show the built-in actions. Then we can see the UI left, right, up, and down right here. So we're just going to add another key by going to left. And I want to add an A. I don't want to use the physical key code, just the default key is fine. A is going to be left, right. Type in D as it's listing, no physical key code. And do the same for down with S. And where's up? Up is going to be W. I accidentally added D. To delete a key that you don't want, you can just press the trash icon next to it. And then if we want right, yes, we want D. There we go. A is left, D is right, W is up, S is down. Yes, that makes sense. So because it's tied in the same action, now when I start the program, I can use those inputs and it'll move the character as I expect it to, and the same for the arrow keys. So either one works, which is wonderful. All right. Now that we have the players set up, let's get started on, oh, and just to make sure that we're not crazy, I'm going to try to move off of the screen, and I can't do that. It's physically stopping me thanks to the walls right there. Wonderful. All right, now let's get started with adding some agents. That's exciting. So actually, this will probably make more sense if we just add a new scene. Go to new scene. And then let's name it agent, and we're going to add a sprite to that, sprite 2D. Going to add a collision shape. We're going to set the collision shape to be a circle. Actually, let's add the sprite first. For the default texture, I'm going to want the default picture. Perfect. So let's change the collision shape to match that. And now let's add an area 2D under that, and then it's going to want another collision shape. There we go. And we also want that to be a circle. And in this case, this area 2D is going to represent the vision of this agent. So how far in any direction it will be able to detect other agents and players in its area. So why are you complaining? Interesting. I apologize. I meant to make this a kinematic 2. I apologize. I meant to make the head node for this scene to be a character node, not a node 2D. So if you want to change the type of a node, you just go here to change type, and you type in character, because we want this to move around like a player. There we go. So, and now that infers that, this child collision shape is my hitbox, but this area 2D is a separate thing for my vision. Wonderful. So let's drag one into our scene. Let's name it agent, the scene name. So to add an external scene into your project, just go to agent, then just drag it in like this. And that's a little big, so we could scale it down by typing S, and that changes to the scale tool up here. and then we can drag down. First, let's select the agent, then we can hit S to scale it down, and we want to be uniform. Let's do Shift. Let's make it a little bigger than the player. It helps the player move around successfully. Let's see what that looks like. Ooh, that's pretty big. Let's make it just a little bit smaller. But we want the player to be a little bit smaller than them. Yes, that sounds great right there. Wonderful. Also, I just realized that by default, it assumes that the way it's going is to the right. So let's make the sprite reflect that by rotating it by selecting the sprite, then going R to the rotate mode. I'm sorry, E to the rotate mode, and then you can just click and drag. And we want to hold Control as we do that so we can snap it to the grid. And as we snap, we want to snap just this way, and this will rotate the right way as it moves. Wonderful. That makes way more sense. Okay, so let's start writing our agent script by going to Agent and clicking here to attach a new script. And that's perfect. Agent script is fine. All right, now let's just set some variables up here. We're going to create a array called agents IC, which is going to be populated with all of the agents, including the player, that it is within its radius. And when an agent leaves that radius, it will remove it from the script. This way, we don't need to check the position and states of all these other agents in the entire scene. We just need to care about the ones that are close to this one and how they're going to affect it. Let's also create a speed variable, and let's make it a little bit smaller than the player, say 200. We're going to create a random range. We're going to create an onReady variable with the onReady tag, and then we're going to call it sprite. And this will change the sprite of this agent depending on which state it's in. So we're going to call it a sprite 2D. And it's going to be referencing the sprite object attached to this script, which is literally this name right here, sprite 2D. That's what this $sign means. It's attaching this direct child sprite 2D right there. And now we can change that later. So let's grab the sprites, say default sprite, preload. We can go to assets default. Then we want to just duplicate this by holding Control-Shift-D. Then we need to do it 4 times. We want a scared sprite, a evil sprite, and a dead sprite. And now we can just go back to assets and then do a /scared. Go back to assets. We want an evil. And of course, for when they die, would like a dead. Perfect. All right. Oh, and of course, very importantly, let's have an integer called state, initialize it to 0, and that will control which state the sprite is going, this agent is going to be in during the simulation. So, to begin, let's clarify the ready function, which is pre-built, and we're going to randomize, because we're going to randomize the rotation of where this agent is looking when the scene starts. And to do that, we can do self.set rotation. And this is going to set it to a certain rotation in radians, the specific rotation variable. In Godot 4, they have new getters and setters for velocity and rotation and that sort of thing for the characters. So this is the new syntax for doing that. It will still work if you use rotation equals this, but this is more efficient, and you're confirming that it's actually going to update the actual rotation of the character instead of maybe missing a frame. So to continue, We're going to set it to a random amount in radians, and you can do that using randf_range, and then that's going to take in specifically two parameters: 0 for where it currently is to 2 times pi, the opposite end of the spectrum in rotations. Perfect. Now, let's actually update some things in the physics process, which will be called every frame. Perfect. So first, let's set the velocity based off of the rotation by going self.setVelocity. Vector. And we're going to set it to be a unit vector standing straight up, 1, 0, which is just a simple vector going straight up, and its magnitude is exactly 1, which is perfect because we're first going to rotate it by doing the rotated command and set that to self.getRotation. And depending on the rotation of the sprite itself, it's going to rotate that depending on where it's facing. And depending on how fast we want to go, we're then going to take this whole vector that's been rotated and multiply it by the speed variable. Beautiful. All right, so to begin, let's start by checking if the state is 0, because we're going to be changing it, and set it to be something like this. And we're going to set the texture through this. The sprite is the sprite 2D node under this as a child of this node, and we're going to set its texture to be the default sprite. Wonderful. Now, we're going to want to update the agents IC array depending on when agents entered this area 2D. So to do this, select area 2D, and we're going to go to the node tab, and you're going to see a bunch of signals that we can attach. Our specific instance, we're going to look for bodies entering and bodies exiting, which will give us the actual nodes themselves. So we're going to go body entered, attach it to the agent script like this, and the default receiver method is perfect. And then we're going to do that again by clicking on area 2D. We're actually going to connect a body exited node as well. So we click on that, and we connect to body exited. Default is fine. So we're going to check if this body that has just entered is in a group, and it's in groups agents. And then we're going to do agents dot IC, agents IC dot append body. And then we're going to check when a body exits, we're going to check that the body actually exists, and then it's going to erase that specific element from the array. Because after it leaves the vision of influence, we don't want to keep checking it or updating things based on that. So that's pretty simple right there. Let's make sure that agent itself is assigned a agents group. And let's do the same thing for our player over here. We're going to manage the groups. And by manage, I mean just simply add the agents group to player. So now we know. And to double check, we can see, nodes in group, node 2D player. and we can check the agent itself after we save. Go to simulation, manage groups, and we'll say, ah, yes, the player and the agent are both nodes in this group. Wonderful. So if we run the program now, you won't see any changes yet because we haven't reflected any updates to state or any updates in behaviors. So let's start with the default behavior, just having it move around randomly, like a normal person. So to do that, let's add some space here and run a move and slide down here, which will update the velocity each frame and also move along that velocity each frame. Now let's iterate through our agents that we see in agents IC and check that agents IC exists. And we're going to do this loop right here for agent in agents IC. And now let's extract that agent to be of a character body 2D type, because those are the specific nodes that we're checking. Going to make sure it's a character body 2D. And then if a dot name is equivalent to player, we're now going to add some behavior for moving towards it, just for demonstration purposes. So now that we know that A is the player, we're going to point ourselves to a rotation. So we can do that using our position dot angle to point. And then set it to a dot position. And we're going to save this to be a desired rotation because we don't want to update this immediately. We want there to be a smooth progression. So I can show you that it can just immediately turn if we just set the rotation immediately to be like that. So, now it's following us. After we leave its field of influence, it's just going to keep moving. And if we're back in its influence, it'll begin to follow us again. Wonderful. We're a little bit faster, so we can escape it. But it's not natural how it immediately twists towards us, breaking its neck. So let's use a lerp function to make this way more appealing. And to do that, we're just going to set a variable out here for desired rotation. Set it to be, we'll just set it to be 0 for right now, for when it starts. And we're going to set desired rotation to be equivalent to this. And now we're going to update its rotation, self.setRotation. And we're going to do that by passing it the lerp angle function, which is going to take self.getRotation and then compare that to the desired rotation. We'll rotate it with a weight of, let's say, 0.1. All right. So now it's going to keep trying to align itself to its desired rotation. So if we run it again, it's like, oh, now it's a more smooth snap instead of a snap towards us. It's like, turns around to us. It's hard for me to get out of the radius. It's very fast. Zoom. Turns towards us. Very efficient. All right. Now, instead of it running towards us, let's change the behavior for it to run away from us. Say that we're a disease carrier. So we're going to be using the scared sprite for this. So let's change our code to check for if state is equivalent to 1. That'll be the scared state. We're going to set sprite.set texture to scared sprite. And now, if it does see player in its range, it's going to set state to 1. If not, let's say there's a Boolean out here, var player near, and set it to false. But if it is near, we're going to set player near to true. And after all of that, if player near is not true, we're going to set our state to the default state, because that's what we want. All right, and to change it to, instead of going towards it, go away from it, we can just change the angle to be itself minus pi times over 2. To change that angle, we just have to do minus pi. That'll take minus 180 degrees from that. So if we try it again, now it's moving away from us and it's scared. If we go over here, it's scared of us. Go over here, it's scared of us. We can chase it out of the corner like this. That's where that's nice. Smaller bounding box makes it easier to go under them so they can move away from you. And when it's not near us, it goes back to default happy. Wonderful. That's looking great. Let's demonstrate this behavior with a greater form of agents. So we can just duplicate the amount of agents we have by hitting Control D on all these agents. We just do that a couple times. Now we have a bunch of agents that are running away from us. We're interfering with their default behavior, and you can see these green agents are the ones that are rendered, that are being updated by the player's position. So we are within their viewing range when we see that the agents have gone green. Wonderful. Let's delete all these agents by starting with the bottom one, scrolling up and holding shift, clicking, and then using the delete button to delete all of those nodes and go back with one, because we're going to want to add some more behavior to this agent. We're going to set the state. If it's 2, it's going to be evil, and it's going to actively pursue the other agents in the arena. So we're going to do sprite.set texture to evil sprite, which we already defined above. And we're going to check if the area between the player and the agent is small enough that it's actually touching it. Then it's going to set itself to be evil by changing state to 2. So let's, after we do all that, we know that A is player. We're going to determine if its position by getting self.position.distance, not distance squared 2. In case you're running into slowdown, if you have, say, millions of agents, you can change distance 2 to distance squared 2, which is slightly faster, because distance 2 takes the square root of the formula, but distance squared 2 just leaves it as it is, so that may be a bit faster if you only need that instead of, say, distance 2. But I'd rather do distance 2, and we're going to do distance to a dot position. And if it's less than 60, we are going to set state to be 2. And if state is 2, we're going to completely change the behavior for running agents. We're not going to worry about that. So let's just say all the stuff we've done before, if state is not equivalent to 2, you can do all this. But after it's 2, it's a whole different ballgame. Instead of that, we're going to go else. And we're going to... That's going to be a problem, the if not player near. So let's add a conditional here, if not player near, and state is not equivalent to 2. Yeah, that should fix it. Because after it's evil, it's going to be seeking out everyone, including the player, so we don't care. We don't want it to go back to its default state. So in this case, let's go through checking the smallest distance. We can do that out here with smallest distance. And let's just make it a big number like this. And we're also going to want to keep, actually, no, we're not. Sorry, changed my mind. And let's go here and check if the smallest distance is greater than the position dot distance to a dot position, and the self dot position is the self dot position distance to a dot position is greater than 1, because sometimes it can detect itself as one of the player nodes that it's trying to find. So we don't want it to try to find itself, so we're going to want that to be greater than that. And we need a colon after that. So to recap, if the distance of the current element that we're iterating through is smaller than the current smallest distance that we are keeping track of, and we're making sure that it's not ourselves, so that means that if the position is 0, we don't want that. We want only positions that are greater than 1 away from us. We're going to basically just set smallest distance to our self distance to current position, and we're going to set at the end of that whole busy for loop desired rotation. It's equivalent to self dot position dot angle to point, and that point is going to be A. And I did oopsie by dismembering it that way. There we go. That should still have a and a dot position is what I wanted. There we go. So gets close. Oh, we're not triggering it to be evil yet. Let's see. Let's make that a little bigger, maybe 90. There we go. And now it travels towards the player. Wonderful. When it's out of view, it then goes about its normal behavior. It's trying to find other people. Wonderful. Let's add some more agents and see how it works with approaching others. So let's change one to be evil. Now they're attracted to each other and they're trying to find each other and infect the others. Wonderful. Like a vampire or a zombie outbreak. All right. If you have any questions, feel free to leave them in the comments below, but this has been a brief overview of that. I hope that you enjoyed, and stay tuned for more Godot content.